What's up, Internet? I'm Nick,
And I am Mario
and this is Rocket.
to the cloud.
Welcome to another episode of Rocket to the Cloud, the interview series where Mario and I talk with leaders and decision makers in software development from many different organizations.
Before moving on to our interview with our guest, we want to tell you that Rocket to the Cloud is presented by Booster.
Booster Framework is part of the Booster Cloud ecosystem and is the most complete solution to build event-driven applications. It's an open source framework that makes use of high-level abstractions and conventions to help you develop advanced event-driven applications focusing on business logic exclusively.
Write your application in terms of commands, events, and entities, and let Booster figure everything else out for you. From the boilerplate code or the API design to the optimal cloud architecture. It even knows how to deploy your code in a true serverless experience. Learn more by visiting booster.cloud. On today's episode, we're going to be talking to Leo Gorodinski. Leo is currently co-founder and CTO of ALVYS, a startup in the logistics space, and for several years he held the position of VP of Engineering at Jet.com.
And Jet and other companies he's worked at, he's been able to successfully apply domain-driven design and event sourcing, as well as make use of functional programming languages like F# as part of their stack.
Leo is a brilliant guy and we had a lot of fun during our interview. Let's check it out. Hello, Leo. Thank you for accepting to be our guest on today's show. We're going to talk a lot of things, but we're mostly going to be centered on your area of expertise, which is domain-driven design, functional programming, and event sourcing. And I want to start out with domain-driven design. We've noticed that you've been a proponent of DDD for many years now. So do you feel that DDD is still something that is sort of novel to many organizations, or it's something that is not widely adopted as it should? Considering that its core concept, that the domain should dictate, the architecture of systems instead of what the technologies are being used. But maybe that's me oversimplifying things. That core concept seems, natural and kind of obvious, but DDD is not something that feels like it's in the mainstream.
I think that when I started learning domain-driven design about, let's say, 15 years ago, I was looking for something that would do exactly what you said, as something that allows you to model the domain independently of the technology that's used to implement it. And I was searching for something like that. I came across domain-driven design, and that's what it's sort of set out to do. But I think one of the reasons that domain-driven design isn't as widely discussed in the broader industry is because as a discipline itself, domain-driven design is actually quite narrow. And I think the domain-driven design book that everyone talks about, that blue book by Eric Evans.
Yeah.
It's it's a good book and it gives it a decent shot. But the problem with the approaches there is that they're so heavily focused on object-oriented implementations. And it gives it the impression that that's what domain-driven design is all about, is just a few patterns of object-oriented design, like repositories, value objects, and things like that. And people become fixated on those, and you see countless libraries of how do you do a repository with even generic types to make it seem more generic and all that stuff. And I think that's the wrong focus. For domain-driven design. Companies have a large need, and even more so today than before, to model their software outside of their programming language. And 15 years ago, when I was getting into it seems to be the conventional wisdom was that the code that you produce is the model. And that's a nice thing because the code is directly coupled to what it looks like once it executes. And so that's a nice way to model. But the problem with that is code and programming languages, even the fancy ones, they're pretty bad at modeling domain concepts once you go beyond the basic things. And so to answer your question, I think the reason that organizations haven't adopted domain-driven design is because it doesn't actually give them that much in terms of what they're trying to do. It sort of attempts to address this problem of defining the domain, but it's completely lacking rigor and a foundation based on mathematics or logic that would allow you to really take it to the next level. Like, it has some concepts like an entity versus a value object, and these concepts do exist in more general frameworks, but it doesn't really allow you to go beyond that. And that's really the problem. That's why you don't hear organizations like Google using domain-driven design, because to them, it doesn't really offer them much of anything. And so the idea of domain-driven design is great. And in my experience at Jet, for example, I talked about it all the time. I talked about, let's create a domain language, let's define the model, and then the implementation separately from that. But that's sort of the end of what you gather from domain-driven design. And we've actually developed techniques that are based on more formal concepts from logic and category theory that do allow you to model the domain in a truly independent fashion of the implementation, but then still map it to the implementation in a principled way. So hopefully that answers your question, and that's sort of my take on domain-driven design.
You have a blog post, and when you talk about, the two sides of DDD. One is the quote unquote tactical, and the other is the more strategic side. And I'm getting the impression that developers usually get hung up on the tactical side, but we miss out on the strategic side, which is the one that involves communication with the domain experts, and creating a domain language, what you talked about just recently. And I think that is closest to the heart of DDD. Is this shift from tactical to strategic something that you experience yourself as you move to a more senior or leadership role inside different organizations you've been at?
Yeah, so I think I think this is true in general, that you have, on the one hand, when you're building a product, you have on the one hand the requirements of the product itself, the users. And then you have, on the other hand, the requirements of the implementation and the solution space. And so engineers, they tend to be fixated on the solution space, on building the actual product, and that's their right fixation. That's what they should be focused on. I think that as the product gets larger and the organization that develops the product gets larger, it makes sense to sort of have a division of responsibilities, and then you tend to have engineers focus more on the technical aspects, and then you might have like a product manager that's focused more on the product aspects. And in that sense, you can say that strategic domain-driven design thinks about a broader scope, and it is a natural progression for somebody navigating from being a junior engineer to more senior engineers. They start thinking about these more strategic concepts. But I think one of the problems with the domain-driven design book is that it doesn't really talk about this, right? And left it to all these people to interpret the Holy Scripture. What might have Eric Seventh have said? He probably meant this. And I think people spent a lot more time just ruminating over what he might have said than creating a new theory. There hasn't been much since domain-driven design. There's like a new red book by Von Vernon, which is a great book, but it doesn't really offer anything new in terms of the modeling tools and technique. It's the same old stuff, just in a more modern light, with some more modern techniques like actor models and concurrency and all that stuff. But yeah, going back to your original question, I would say that I think it is a natural progression for an individual developer to go from tactical to strategic.
Especially when trying to adopt like DDD in organization like startups or even large enterprise, what do you think will be like the biggest obstacles in order to adopt it?
Well, I think the biggest obstacle in getting it adopted is that people don't really know what it is, right? Like, you're saying domain-driven design, and then you're going to tell them, oh, it's the domain language. Well, can you point somebody to a rigorous theory of what domain-driven design is and how to actually use it? There's a lot of interpretations of what it might be across the internet, and everyone has their own take on it. But I think the biggest problem is that it doesn't sit on a rigorous foundation, and that's why there's so many ambiguities and misinterpretations. It's not to say that you can't build something like that. I think you currently certainly can, and I'm a big believer in investing into this kind of technology. I just don't think domain-driven design gives you anything with enough sophistication to allow large enterprises to use it in an effective way. I think that domain-driven design really shines when you go away from that like CRUD app to the next level of having more complex domain objects. And that's a nice guide to take you through that level. But when you're talking about industrial grade software at the scale of Walmart and Google, domain-driven design really doesn't give them much of anything in terms of just some mumbo jumbo lingo that doesn't really get you anywhere. And I mean, that's true for a lot of object-oriented design patterns too. Like people start splitting hairs on what's really a singleton versus a factory and all that stuff. And there's all this fixation on these things that I don't really know how they relate to the broader area of computer science and mathematics and logic. And so I think there's just a lot of fixation on these things without really understanding how that helps you build software. And you know, who am I to say that that's not the way we should go about things? But that's just the way it seems to be.
Could it be something like related to that, something lacking in the education of software engineers, and it's like everything is super focused on this tactical perspective that you talk about instead of the strategic one?
Well, I think I wouldn't even say. I think that in some sense there's a lack of focus on the tactical aspects, and I think the education of software engineers is very much lacking in general, both in the tactical and the strategic aspects. I would almost say that I would agree that I think that software engineers overlook the strategic aspects a lot more than they tend to overlook the technical aspect. And this is something that as an engineering manager, engineering leader, I've dealt with quite a lot, is where you have people graduating college and they went to the top schools and then they enter the workforce and they realize that their technical skills account for maybe 10 to 15% of their success as a software engineer. And it's the other skills, the more softer skills, or the communication skills, the ability to work in a team. Those are the things that really account for the vast majority of your success as a software engineer. But that really has nothing to do with domain-driven design, tactical or not. That's just a broader, it's a much broader matter. But with that said, education even on the technical side, on the tactical side, is lacking for software engineers. It's a bit like a wild, wild west, and that's why we have things like design patterns, which it kind of makes sense, but they're kind of a bit blurry in terms of the foundation that they rest on. And I think this will change. I think this is still an early discipline, software engineering, compared to other engineering disciplines, and so we still have a ways to go before making it formal. But people are trying. There's a lot of exciting things happening on applied category theory side and being able to use that for some serious domain modeling. But this literature, this writing hasn't permeated the broader software engineering community yet. But I think it's on the verge, and there's been things done before that. Like you guys might know about Leslie Lamport. He's kind of a famous name in the context of distributed systems. Well, he was trying to solve this problem too, and he came up with a language called the temporal logic of actions, which is a specification language for distributed systems. Now, this is getting serious. Now, this is actually allows you to express temporal invariance and logical invariance to the extent that domain-driven design doesn't even come close to offering you the tools for doing. And so, so I think that I agree with you that a formal education for software engineers is lacking. But there's some things on the horizon that are quite promising, in my opinion.
Yeah, that's actually quite funny because you mentioned like the TLA, and and I actually use TLA plus, but never stopped to think what the acronym means actually. so
yeah.
So getting back to DDD, DDD usually goes hand in hand with event sourcing, and we know that you've applied event sourcing over when you worked at Jet. So how did you discover event sourcing? Because that's a different way of looking at the way that you handle and store data.
I think that this is another example where if you don't pay attention to any of the software engineering literature, you could have come up with it yourself by just studying basic computer science, and not even computer science. Like the way that event sourcing was evident to me was not really through event sourcing, but through just understanding how state machines work and understanding. So what is a state machine? If you just try to understand that, there's no mention of state machines in the domain-driven design book, but to me, this is the whole central aspect of how you should discuss these kinds of systems. And a state machine is basically a collection of states and a rule for transitions between those states, right? So if you look at a state machine and you think like, well, a state machine can represent any kind of application state. Like you have input commands, you have output commands, and you have states that change in between, and the transitions that go along with that. And if you just look at those essential things about a state machine, very easy to understand. Everyone should be able to do it. If you're able to do any kind of coding, you should certainly be able to understand what a state machine is. And if you just look at a state machine and you try to use that model to model any kind of scenario that you have, like a jet, we had a shopping cart. So I said that, okay, a shopping cart, we have a state corresponding to the state of a shopping cart, which is somebody's current set of items in their cart. But then we have inputs into the system, which are requests to add items or update items. And then you have outputs of the systems, which are messages that indicate that an item was added or that there was a failure to add an item. And if you look at this definition and you try to then factor the transition function in different ways, well, your overall transition function takes an input and the current state and produces the new state and an output. And so then you could start thinking about, okay, well, I need a storage mechanism to store the state, which is something that you can do. And this is what folks typically do with a CRUD type of application. They have a repository to store the state. They hydrate it and persist it back. But by looking at the state machine, you could also see, well, this is one way to store the transition, but you can also simply store the output event. And if you can create a function that takes an output event and then provides a state transition based on that, then this is yet another way to reconstitute the state. So really, event sourcing is just one way to looking at a state machine and coming up with different ways to compose it out of pieces and finding different ways to reconstitute the state. So in that sense, I think that event sourcing is just a completely obvious thing. But I think that if you do follow the literature on software engineering and any of those like enterprise application architecture books, you're going to end up with like a repository and something really weird looking without looking at the essential underpinning of what's really happening. And by using this framework of a state machine with inputs and output events throughout our engineering training and throughout our modeling at where I was at JET and where I am now, I find this to be an extremely valuable tactic to use, much more valuable than like the repository pattern, for instance.
That's great. And how was your experience like implementing event source systems in the different organizations you've been working with?
Well, so at JET we implemented event sourcing at a fairly large scale, and we even had a formal rule in our organization that when you're building a new system, you have to do event sourcing. And if you don't want to do event sourcing, you have to explicitly ask for permission to design your system not event sourced. And the reason is that we've invested quite a bit into our event sourcing infrastructure, and we saw the benefits that it gave us. And there's a lot of benefits to event sourcing that folks don't really talk about because they only appear at a large scale. And one of them was actually one of the properties we sought to gain from event sourcing was fault tolerance. And the way we got that was we started with a single event store in a data center, and it was replicated as a cluster of event stores. But we saw a need to have a geo-replicated system. So even though that we're replicated within a data center, we would have outages in a data center, not necessarily due to the data center itself, but maybe our own software inside of it was performing poorly. And so we saw the need to have a geo-replicated system. Now, with what we were able to do with Event Store and an event log is that we replicated the event log, and then all the downstream systems that are attached to it would be replicated for free because they're already consuming a stream. They don't really care which stream they're consuming. Either they're consuming a stream from one region or another, it doesn't matter. So by replicating the log, we we had a bootstrapped replication, geo-replication for all these other downstream systems that we were using, such as Kafka, Elasticsearch. And so it gave us those incredible fault tolerance properties that we would have otherwise not had. Another really nice thing about event sourcing in an organization is by using it as a form of communication, not just storage, right? It solves storage and messaging for you. And messaging using a log is much more effective than messaging using a queue, because when you're doing messaging on a log and you're developing a service that needs to consume some stream, well, when you're testing it, it's much easier to just reset a pointer back to the beginning of the stream and rerun the process to see what the output is than to repopulate the queue. So there's a lot of handy aspects to event sourcing that are great for large organizations. And this is not even talking about the fact that you have a history of all the events. We had a really cool use of this once we were acquired by Walmart, and they wanted all of our shopping events. And so we streamed it to them. They wanted all the activity on the shopping carts, not just the final output, but they wanted the activity on the shopping cart. So having that history is also important for that reason. But it doesn't require an investment into the infrastructure. Like we have to build our own replicators and failover mechanisms. And we have to make that investment into the infrastructure, including the monitoring infrastructure for such a system, because it turns out to be a very asynchronous system. Things are all happening independently, but you still want to have an accurate understanding of system states, and it takes some time and effort to invest into those pieces of infrastructure.
So, Leo, you mentioned a lot of advantages from a technical perspective, but what about advantages from like a business perspective?
So from a business perspective, one of the things I mentioned before was just having that transaction log of all the things that happened in the system. This is extremely, extremely important. And I think it's helpful in all sorts of systems, in particular financial systems, that you want to have a record of everything that happened. But also we used it in our product catalog system and the shopping cart system. And from a business perspective, having access to that history is just extremely, extremely important. And it's not even so much like the history from a business perspective, even from a technical perspective, helping you debug system states. That audit trail is invaluable. Having operated a system that wasn't event sourced after that, I really feel the pain of not having that event history and understanding how things got the way that they are, understanding why there might be an issue. So from a business perspective, that's extremely important. The other extremely important part from a business perspective is more so on this like domain language side, which is that the events that are going into these event stores, they should be business concepts. Like everyone should know about the events. And the monitoring of our system state was essentially a monitoring on these streams of events. And so, for example, sometimes we would have slowness going on. Like we had at some point, we had a scenario where one of our merchants infused a whole bunch of product updates into our catalog, like a lot more than we were ready to take. It was like 50 million updates, and we had a backlog on that queue. And that was like, that was like a business condition. It's like we're backlogged updating this product queue, which means that these merchants aren't going to be able to update their product data fast enough. It's well beyond our SLAs. And so using these events, and there's the streaming concept that things don't happen all at once. This is an important concept from a product perspective and a business perspective. But this is actually also another example where you might get pushback from the business team because they don't like the idea of things happening asynchronously. So we had that situation, for example, where we have our product catalog and it produces a stream, which is then indexed into Elasticsearch. Well, that's an asynchronous process. Once we publish a message into the stream, we don't really know how long it's going to take before it's indexed. We have some bounds, but we don't know. It's not a synchronous operation. We had some requests once in a while to like take down a brand that didn't want to sell on jet.com anymore. Well, they expected that to be done instantly, but sometimes it would take hours before that update would take effect if we had a backlog. And so that was actually a big issue because they wanted things to happen right away. And so you're sort of selling them more asynchrony, but hopefully the system will behave better as a result. So you have to be careful with the way that you sell it to the business team because the savvy business teams will know that, hey, if it's asynchronous, how long is it going to take? How long is that delay going to be? Is there any way we could force it? So you have to look at it from both sides.
And what would you say that were the biggest challenges you faced when implementing these kind of systems?
Well, we had just some set of challenges from fear of the unknown from the other engineering folks, because they haven't done this kind of thing, and they would just jump to their default like, oh, this won't scale, this doesn't work, blah blah blah. Who does it this way? Like we had a lot of folks, for example, at Jet that came from the finance world, and they're used to using these like big box like messaging systems that did everything for them. Certainly not used to event sourcing, so it just took some evangelism to get them to adopt this new style. We didn't really have any issues with the business teams. I think that they appreciated our focus on the domain language and these events that really clarified things for them. But it does take a lot of evangelism within an organization, because you have to convince a lot of engineers to do it, and you have to really sell it to them, and you have to not only give them the idea, you have to give them the tools for implementing it. That's certainly one of the things you learn in a large organization, is that if you want to try out a new library or a new coding trick, like, you don't just do that. You have to find a way for everyone to adopt it, everyone to use it and debug it and all that stuff. So in a large organization, you actually try to minimize change. You try to minimize snowflakes and try to keep things consistent. But businesses definitely do appreciate a focus on the domain.
You've mentioned before a lot of different tools that you used when you've invested in the infrastructure for an event source system. I think you mentioned Kafka, Elasticsearch. I think you mentioned also Event Store. What do you think of the current tooling that there is out there for implementing event sourcing?
Well, I
think your experience,
I think event sourcing has really become more mainstream. If you look at DynamoDB and Azure Cosmos DB, they both provide change feeds. In fact, Azure, they developed a change feed in conjunction with working with Jet, because we were asking them for a change feed, and they didn't have that kind of product before. There was some discussion of actually embedding Event Store into the Azure product, but instead they gave us something better in some ways, which is the Azure change feed. This to me is really one of the most important steps to building an event source system, is this access to the transaction log of a database and being able to consume it downstream. But with that said, we did migrate some systems to Cosmos DB at Jet. In fact, one of the systems we migrated was our inventory management system, which was then adapted to manage inventory for all of Walmart, including the stores, not just Walmart e-commerce. So it was a huge undertaking. And to build an event source system of that scale, you have to do a bit more. So it was indeed stored in Cosmos DB. But one of the things you have to do at that scale is you have to create a cool storage mechanism. Is that you can't keep all the hot events in the primary database, because even though it's partitioned and sharded and all that, and automatically so for Cosmos DB, you're charged on a per shard basis. And as the number of shards increases, you start getting charged a lot more, and operations on shards become more costly. And so to scale that, you need to develop a mechanism for archiving older events into a cheaper, cooler storage mechanism, but then still being able to access all of them when need be. Another thing that really starts to become a bottleneck at scale is the ability to reprocess the stream of events. Right? As the streams get arbitrarily large, you still want to be able to run computations on them. And so once they get beyond a certain size, the only way that you can sensibly do that is by offloading them into a data lake, for example. And then you're able to run MapReduce jobs on that. But you have to build infrastructure to tie this all together, so that if you have systems that are processing events, for example, one of the things that we had to do was we had to build this stream processor that would automatically shift from cool storage to hot storage depending on where it was in following a given stream. And this was very important, because we started to realize when we did like a backfill job on an old stream, and if it was accessing the primary database, it would start to affect customer traffic if we're doing a big replay on that database. So we had to isolate where the data was stored and provide different access patterns for accessing historical data versus real-time data. But once you do that, once you have a pattern and a framework for doing that, it becomes easy to repeat it.
Imagine that there was this tool that has like all the required features that you need, and it's like ideally perfect. Like, what will be those features and those things that this tool should have in order for you to consider it part of your tool belt?
Well, you mean do you mean specifically about event sourcing?
Yeah, DDD and event sourcing.
Or
Yeah, both of them apply here.
well, I guess so. When I was early on at Jet, I was trying to evangelize a few things. One of them was functional programming. Another one was event sourcing. And the evangelism is not enough. And this is one of the big lessons I learned about getting things adopted in organizations is that you could shout from the rooftops that event sourcing is great, which is important to do, but you have to do a lot more than that. You have to create a whole ecosystem and support structure around what you're doing. And at Jet, we had a whole team that was dedicated to maintaining and developing this infrastructure that consisted of libraries and actually running services, and most importantly, a support infrastructure, right? So that if you build a piece of infrastructure and now you have other engineering teams relying on that, well, it's certainly glorious for you, but what if there's a production incident and the issue points to this library that you have? Well, we had to account for that. And before I could ship a library to anybody, I had to provide a support SLA for that so that I would have to agree to get paged at night if something happened. And those are the things that are the real challenges in getting things adopted in large organizations. But those are the things that you have to invest into when you want to get a technology adopted at a large scale.
So, Leo, getting back to what you said, that at Jet, you guys made the decision that every system should be event sourced. I want to, if I recall correctly, I think it was Greg Young at one of his lectures that he said that one should apply DDD and, as a consequence, event sourcing, in the parts of your organization that the data presents a competitive advantage. Would you agree with that?
Well, I think there's truth to that, right? Because it does require an investment into the infrastructure to make event sourcing work. So if you just need a very simple thing to be done, then it's not worth the investment. But the other factor you have to consider here is that if you are in a large organization that has made an investment into the infrastructure, one of the most important factors in organizations is reducing the number of snowflakes, is keeping things consistent. And so in that sense, if you're building a system and event sourcing might be overkill for it, but you already have the infrastructure to make it work and a support structure to make it work, then it is actually better to keep things consistent and make it event sourced. And it's true, there is a lot of, I think that the real sentiment for what Greg is saying and what others are saying is that you got to use the right tool for the job. And you have to really make sure that what you're doing is a benefit to the product that you're building. As engineers, and God bless our souls, but we love building. We love building things, and this is part of what allows us to provide values. That we just love doing this stuff so much, and we'll do it for free. But sometimes we kind of get carried away, and you build this monstrosity, and it kind of works, but it's certainly been overkill. So it's something that we have to do as professionals, is keep a check on that tendency to over-engineer. But I think a blanket statement saying that event sourcing is only used for some of the things, it must be qualified a little more, right? I think the true sentiment is don't use overkill solutions for things, but it depends on the context to a large extent.
In many of your posts and also throughout this conversation, we've talked a little bit about functional programming and that you were an evangelist of functional programming at Jet. And actually, I'm a Hascaller myself. I got this very nice T-shirt that Philip Wadler was selling some time ago, and I would like to know more about your perspective. If you have found much resistance from developers when choosing to use a functional programming language as part of their stack instead of using a procedural language or object-oriented one.
Yeah, yes, there's certainly resistance in a similar sense as there's resistance to event sourcing. So at Jet, we actually, when we started, I was one of the first hires at Jet. So we hired the engineering team first. I was the only one that was pushing for F#. I was the only one that knew F#. And so when we started, we were doing C#, but I was doing F# for my stuff. Like the CTO said, all right, Leo, you just do some F#. We'll see how it goes. And then about a month in, the CTO, without knowing F# himself, he just said, let's convert everything to F#. And I think what he was looking at was that he wasn't looking at the language itself being better, because he didn't know the language. Like, sure, he heard me yelling every day that object-oriented programming sucks. But what he really looked at was that, like, oh, wow, this guy Leo, like, he'll do anything to program in F#, it seems. Maybe there's others like him. And we really capitalized on this enthusiasm that people have for functional programming, is that, like, you're sitting here with a with a T-shirt named after your favorite programming language. I mean, who does that? And from a leadership perspective, this is extremely valuable, because if you get engineers that love to do what they do so much, then you're gonna get a better engineering organization no matter what. And I think this is what the biggest win that we got. It was that, sure, the language was nicer and more succinct, more terse, and all that stuff has a more powerful type system that allows you to express invariants that you couldn't in C#. And that's all great, but I think the biggest win is just attracting those passionate engineers, and that we use that to great advantage at JET. But there is resistance, just like to anything else. Like there's fear of the unknown. And if you have a senior engineer that's been hacking in C# their whole life, and you show them this new tool and they don't know anything about it, of course there's going to be some resistance to it. But I will say, though, with functional programming, I went through almost like a religious transformation when I immersed myself into functional programming, because I thought, like, oh my God, what was I doing my whole life before this? Like, what are all these people doing with object-oriented programming? And I think I went through a phase where I was like a functional programming fundamentalist, and I thought, like, everything should be purely functional and everything else is trash and all that stuff. And that's all great and all, but I would still ask any Haskeller to show me any evidence that functional programming actually is better. There's a lot of anecdotal evidence that says, like, well, we rewrote the system in Haskell and now it's better. Well, if you rewrote it in C, it would have been better. Rewriting a system is not a good measure of something being better. So I think to me, the biggest thing with functional programming is not the programming itself. And believe me, I spent a lot of time learning and discovering functional programming. And one of the best things about functional programming is that there's a lot more in terms of patterns that you have in comparison to object-oriented programming. So if you got into object-oriented programming and you were a little disappointed to learn that, like, design patterns, that's all there is, there's nothing beyond that, well, then functional programming is for you, because that's a lifetime worth of discovery and learning. And that's great that you do that. But again, I think that if you were to ask me whether I would deploy Haskell in an organization, I would probably say no. Just because, well, I don't know if you want to talk about that, but that's my response.
Yeah, we'll have another podcast episode for that. And what was, like, the reaction of those senior engineers that were coding all their life in C# when you say something like Monad?
Well, the thing with Monad and just the broader situation there's kind of problems on both sides of that camp. I think it's true that object-oriented programmers are a little bit unfair when they complain about monads, yet they're talking about, like, singletons, factory, fly weight, or whatever all day long. And so that's like, they should just take it easy and realize, hey, maybe I should just learn something. But the other side of the problem is that, like, with the whole situation we've had with like Monad tutorials, and I do think there's a tendency on the functional programming side with these more elite programmers to try to make things a bit more complicated than they are, and to make things more fancy than they are. And this obsession over monads, I think, is a prime example of what's been done, because they made monads seem like one of the most mysterious and complex things, which they're not, and they made it seem like it's like the holy grail of functional programming, which it's not. Monads have, in fact, a much broader and much bigger role in mathematics and category theory, and they're one of the things that you have to learn to make sense of everything else. But in functional programming, you would think that that's like the holy grail. Like, once you learn that, then you know the rest of functional programming, which is simply not true. So to answer your question, there's problems on both sides. I think that there's irrational fear on the side of the folks that have never seen it before, and there's overly eager focus on academic terminology from the functional programming community, and they're both, I think, doing a disservice to each other.
Yep.
But that's my thinking.
Yeah, absolutely. It's like the sentence that's like, well, a monad is just a monad in the category of the functors, and like probably like not many people know about that, but they just say, as you say, just to keep things a little bit more difficult.
Well, there's other ways. There's other ways to say it. A category is a monad in the category of two spans, and there's all these different ways to slice it. That functional programmers would never hear about something like this, but monads are very popular in the popular. They're an extremely handy tool in the context of category theory, where you think of them not as like these computations, but more so as algebras, these algebraic structures that you can combine things into one thing. And it's just a higher order version of that. Again, I think that functional programmers know so little about monads, yet are so eager to talk about them, whereas the object-oriented folks know so little about them, and they're so eager not to talk about them. And in both cases, it's a little wrong, I would say.
You mentioned that you used F# over at Jet. And you've made a great case for F# in your blog as the language for DDD and event sourcing, instead of, C# or other object-oriented programming languages. How did you come to this conclusion?
So when I wrote that blog, so that was almost 7 years ago, and I think that I probably agree with most of the things I said, but maybe not some of them. The way I came across it is that going back to this framework that I mentioned earlier about state machines, and so this is how this is my go-to technique for modeling any system, is model it as a state machine. And when I was doing that, and then I was writing the implementation in F#, I just saw such a beautiful correspondence. So you have the algebraic data types in F# and other programming languages, just like the product and the sum types or discriminated union types. Having those and having a more functional approach where you do think of state transitions as being explicit transitions, right? So you think of a function taking a pair of input and state, producing a new state and output, and that just connects directly to the concept of a state machine. In object-oriented programming, the same thing happens, but it's a bit more encapsulated, right? Because the state, you don't explicitly transition from input to output. It's just a state of the object that's inherent and associated to the object itself. You don't explicitly express the state update. And I think that's part of the reason what really makes object-oriented programming more difficult, because it is just state, right? And these operations on objects modify state, but you don't express that state transition using a function type. It's just an implicit change, but I think it hides a very important thing, that state does indeed change. And when I just did those first few lines of code in F#, I realized like, wow, this is something special. Because then the other thing that functional programming tends to force you to do is it has you write code to where you define code as a data structure, and then you interpret that data structure. And in the context of the domain-driven design, that made a lot of sense, because you could have a data structure representing domain logic or an entire workflow. And then one interpretation could be running a test on it. Another interpretation could be attaching a repository to it and actually persisting it. And so thinking about a program as a data structure and an interpretation of that data structure, I think is a very helpful concept for software engineering in general.
F#, correct me if I'm wrong, but I think F# kind of like Scala, it's kind of like a hybrid. It has some object-oriented concepts, like classes and that kind of stuff. And that could be used really well, for what you just mentioned. So getting back to Haskell, not to pick on Haskell, but do you think it is possible to use a purely functional programming language like Haskell for implementing, domain-driven design and event sourcing?
Yeah, I mean, there's a lot of things I would have loved to have from the Haskell type system in F#. So F# doesn't have higher kind of types, and those would be really handy for implementing this monadic interpretation system that I talked about earlier. So you could have for example, in Haskell and even in Scala, which has a more powerful type system, they've done a lot of these free monad interpreter constructions, and those would be really handy to have in F sharp, in my opinion. The biggest roadblock to getting F sharp adopted, even we had the issue with F sharp, it being on the .NET framework, is just the ecosystem and the compatibility.
Yeah.
A lot of time getting F sharp to work on .NET Core, and it was like a year-long project to get us to shift over to .NET Core so that we could run on Linux containers and on Docker and things like that. We always struggled with libraries, right? Because it is on .NET, but then if you want to consume a C# library from F sharp, you usually have to build a little wrapper for it to adapt it to the style. And so we were just really stuck in a sense of getting access to libraries. We had to build our own Kafka library, and it's not, it's not fun to do. I mean, it is kind of fun, but like it's it's not the best use of an organization's time. And the same thing with Haskell. Like I love the Haskell language, and maybe I would like coding in that language, but the ecosystem is a much more important aspect than just the language itself.
If you had those roadblocks using F sharp and the .NET framework, why did you guys not use Scala then, which is all JVM based?
Well, we were kind of locked into the .NET framework already, and it's those are reasons kind of before me. The CTO had already selected the .NET framework. Part of it, he's already had experience with it. And part of it is that we definitely knew we wanted to be on Azure, because we definitely knew we didn't want to be on AWS. And .NET is kind of like a first-class citizen on Azure, so that just made sense. I do kind of think that I'm happy we didn't actually use Scala, because Scala does provide a more powerful type system. It does have those higher kind of types, but I feel like Scala just gives you so many ways to shoot yourself in the foot. And that I'm glad we didn't do Scala, and I miss those features. But like they have a few things like about their like globally available functions or something like that. I remember looking at that and thinking, wow, this is a good way to mess things up. And then because it's so powerful, I feel like there's so many different ways of coding it. Like if you look at those like Scala Z libraries or those CATS libraries, it's like, what are you guys doing? I mean, I know this is cool to do category theory, but like, are you really making things better this way? Like, or is this just you're just showing off or something like that? So I'm glad we avoided all those rabbit holes with Scala. This is what I was trying to I was trying to sell this to the broader Walmart organization, is that I know you guys have Scala because you're already on the JVM, but F sharp actually gives you some serious advantages over that, and I would still stand by that.
Absolutely agree. Like, especially in the Haskell community, you can see like people getting abstractions on top of abstractions, and then everything gets super complex. But coming back again to the ground level, it's like nowadays they're like Java, C#, and all these mainstream languages are adopting more and more functional features. And do you see this positive, or do you think it's like it's taking away momentum from companies moving to stuff like F sharp, Haskell, Scala, whatever?
No, I think this is like, really this is like the way things should be, in a sense, is that like you adopt some functional programming patterns that make sense, but you don't go full functional just because like the going full functional is like, I struggle with that, because like I would say maybe I'm more mathematically oriented than the average software engineer. But I still like, and I don't get me wrong, I love coding up those like Haskell abstractions and like lenses and profunctors and all that stuff. That's fun to do on the side. But like, even now, it's been a couple of years since I coded in Haskell. Like, I don't know if I'd understand the code that I wrote before. And so I don't know. It's just like, I think there's a lot of, there's no evidence in functional programming. There's no studies being done in functional programming that actually measures the efficacy of programming languages. Like, there's anecdotal evidence, and promoters of programming languages will reference that. But I think taking a more, quote unquote, practical look at things is valuable. And I think they've done some good work with that. Like C# is adopting a lot of F# things that have been in F# for a while. But why not make the lives of C# programmers better without being completely pure? So I think it's a good thing, and that's how things should be done. Is take the good things and try to make incremental improvements to the language rather than trying to change the whole world, because sometimes that's the right thing to do, but if you don't have any evidence to support that, then why do it? Again, I think there's probably ways that you can demonstrate that functional programming is superior, but when you take it with all the other factors in consideration, I'm hard pressed to make that claim.
Yeah, absolutely. And as you said before, it's like in the end, like what matters is the soft skills, the team communication, how the team works with each other. And actually, there's this list called like Awesome Cold Showers or something like that by Hillel Wayne, and he's like constantly saying, well, you say that functional programming is superior, but here's an evidence that's no evidence about it, and so on, with like formal methods, functional programming, object orientation, and a lot of stuff.
Yeah, and formal methods. I mean, there's a perfect example. Like we at Jet, for example, we because we had enough nerds in the house that we did try to specify our replication system using TLA plus. That was fun to do, but it was completely useless. What was much more useful was building a real-time verification system that would be just looking at the streams and making sure everything is there, kind of thing. So there's a lot more value in things like that in terms of making your systems run well, is that actually running instances of the system and testing them rather than trying to create a formal model that specifies the system.
So you spent quite a lot of time at Jet. Was it like 4 or 5 years or something like that, where you were chief of engineering, right?
Yeah, well, I was VP of engineering, but I had a boss, and so I wasn't the chief engineer. But I think I was mostly the one engineer associated mostly with like our technical choices and architecture and things like that.
Right, and then you went over and co-founded ALVYS. Is that correct?
Yeah.
Right. So, what did you learn, and what are you trying to apply over at ALVYS based on your experience and what you've learned at Jet? What do you think you're doing better now over at ALVYS that you could have done better at Jet?
Well, yeah. So ALVYS is a project I've been involved with for the past several months. So it's a new thing for me, but we are moving along. We do have an engineering team, and we're building a product. We actually have paying customers already, and I am really looking forward to what comes next with ALVYS, because this will be an engineering team that I get to build entirely in my own image, so to say, and with processes that I believe are important. And so some of the things that I'm doing now that I didn't do before at Jet, but I should have, is I'm actually spending a lot of time creating a knowledge base within our Notion workspace that basically describes all the things that I think are important about software engineering, and topics from distributed systems, from machine learning and CS fundamentals that pertain very directly to how we build services. So I'm creating a whole knowledge base, and some of the things I've had from before, but I want to invest a lot of time into having a very, I guess, rigorous engineering process. And the way that we build software, from discovery to specification to implementation and testing, I want that to be done in the best possible way, and for us to use principles to the extent possible in doing this. So one of the things I'm doing from an engineering team perspective is making a lot of investments into our engineering culture, but even more broadly into the broader company culture. And one of the biggest things I learned at Jet was the importance of company culture, and how to define it and how to think about it. And so I want to have a really good company culture. And some of the things I tell my engineering team about my management style are that I'm all about transparency and talking about everything that's on your mind. I see my job as an engineering leader is 90% of it is making sure that people understand each other and that people are on the same page. and I'm making a concentrated effort into communication. I'm also making it very clear that one of the important things that I see in a team is kindness towards each other and respect. And a team that works well together, that communicates and is dependable, is far more effective than an engineering team that has a bunch of smart coders on it. And so those are some of the things that I would like to do in my tech organization. But obviously there's a lot more that goes into that. But overall, certainly I've learned so many things at Jet, and I'm going to incorporate these now into ALVYS. And I am really focused on creating a really good engineering culture, the best that I can provide, because I do think it's going to be a strategic advantage for us in building our product and aligning the product with the engineering team. Is having that shared ownership of the product is something I really believe in, meaning that you don't have a culture where the product team just throws specs over the fence to the engineering team, but rather we work on it together, and elevating the tech team to the highest possible level, because the tech team builds our product, and that's the most important thing. And I want that to be part of the culture as well.
Well, we're out of time, so this has been, a very interesting and insightful conversation. Leo, thank you once again for being our guest. It was a pleasure to talk to you. We wish you all the success in, ALVYS, in creating your company culture. The last bit that you told us about.
Yeah, like you said mostly anything, Mario, and thanks a lot, Leo, again. It was like such a great pleasure to talk to you, especially that there aren't much functional programmers out there.
Yeah, you're welcome. Good to be here, and good luck to you guys.
All right, Leo. Bye-bye. Thank you for watching another episode of Rocket to the Cloud.
If you liked this episode, click the like button and subscribe to our channel. And don't forget to click on the bell icon so you can be notified whenever we publish a new interview with another awesome guest. Until next time.
Until next time.